First, in exercise 3.6, this is a proper fraction because the degree of the numerator is 2, whereas degree of the denominator is 1 and 2 together, which is 3. So this is a proper fraction. For a proper fraction, you can do a partial fraction. But first, you must factorize the denominator completely. So we have denominator is x plus 1, x minus 1 over x squared minus 1. But x squared minus 1 is a difference of 2 squared, which is x minus 1, x squared minus 1 squared. Now x squared minus 1 squared can be factorized into x plus 1, x minus 1. So eventually you get x plus 1 plus times x minus 1 squared. So x minus 1 squared repeated 2 times. So this is the case where you have denominator equal to ax plus b, which is x minus 1, times cx plus d squared, where c is 1, d is minus 1. So this is the type of the denominator. Now in this case, because cx plus d power 2 repeated 2 times, so when you do a partial fraction, the term, when you break up, you get a b over x minus 1 plus c over x minus 1 squared. So therefore, this 5x squared plus 5x squared minus 8x minus 5 over x minus 1, x plus 1, x minus 1 squared can be written as a over x plus 1, because x plus 1 is power 1 only, so a over x plus 1, and then b over x minus 1 plus c over x minus 1 squared, which is mentioned in the notes here. b over cx plus d, c over cx plus d squared. But c is equal to 1, d is equal to 1. Now, how do we find the value of a, b, and c? What you do is multiply both sides of the above fraction by x plus 1 times x minus 1 squared, which is the LCD of x plus 1, x minus 1, and x minus 1 squared. So you multiply the least common denominator, which is x plus 1, x minus 1 squared. Then the left hand side becomes 5x squared here minus 8x minus 5 over x plus 1, x minus 1 squared. You multiply by x plus 1, x minus 1 squared. And then on the right hand side, you have a over x plus 1 multiplied by x plus 1, x minus 1 squared plus b over x minus 1 times x plus 1, x minus 1 squared plus c over x minus 1 squared times x minus 1, x plus 1, x minus 1 square. So we actually multiply both sides by the least common denominator, 1 by 1. Now, by doing so, you have log cancellation. So this thing exactly the same to cancel. So you get 5x squared minus 8x minus 5. And then on the other side, you have x plus 1 cancel. So you left with a times x minus 1 square plus another one, the x minus 1 and the x minus 1 cancel. So you left with b times a copy of x plus 1 times x minus 1, because only copy, you cancel one of copy of x minus 1, right? Because this x minus 1 square. So you left with x minus 1. And then plus c, and then you have copy of x minus 1 square cancel. You left with c times x plus 1. So now you have 5x squared minus 5x minus 5 is equal to, now x minus 1 square is a perfect square. So you get x squared minus 2x plus 1. And b times x plus 1, x minus 1, we know it's just x squared minus 1 square, which is 1. Then plus c over x plus 1. C times x plus 1. So in this case, you get in this case, you get ax squared minus 2ax plus a plus bx squared minus b plus cx plus c. After you distribute the term into each of them. Okay, so bx squared as minus b, and then cx plus c. Now we collect all the x squared term together. Let's see how. Collect all the x squared term together now. I have ax squared, bx squared. So these are 2x squared together. So this is a plus bx squared and then you collect all the x term together. Get 2ax plus cx here, minus 2ax plus cx here. So you get minus 2a plus c of x here. So just now I have this x squared. Now I have x now. Then plus a constant. Constant I have equal to a minus b plus c. Where let me color this so that you can see clearer. So it's a here minus b plus c. Alright, so these are all the three terms together, a minus b plus c. So this is on the left hand side is 5x squared minus 8x minus 5. Now, you compare the x squared. This is 5. So 5x squared is the same as a plus b x squared. And then you compare the x here. Minus 8x, negative 8x here, is equal to minus 2a plus c. By comparing the x here, then finally compare the constant. Minus 5, okay, is equal to a minus b plus c. By looking at minus 5 here, a minus b plus c, right? So you have 3 equations, 3 unknown. So how do we find the 3 unknowns? Okay, there are A, B, and C. So let's try to find here. This is equation 1, equation 2, equation 3. Equation 1, we have something like A equal to 5 minus B. Now substitute this into the equation 3 and see what you get. You get minus 5 equal to A is 5 minus B here, minus B plus C. Or let me try another way. So I'm going to use another way. From equation 1, I want to figure out what is B here. B is actually 5 minus 8. Now substitute in the 3, you get minus 5. A minus B is 5 minus A now, plus C. So you get minus 5 equal to 2A minus 5 plus C. So I get minus 5 and minus 5 cancel, then 0 already. So that means that 0 equal to 2A plus C. So C is actually equal to minus 2A now. So this is actually from equation 3. Now I know C equal to minus 2A now. Go back to equation 2. Equation 2 says minus 8 equal to minus 2A plus C. But C is equal to minus 2A. Alright, so this thing going to minus 2A here. So eventually you get minus 8 equal to minus 4A. So that means that A is equal to 2. Okay, 4 times minus 2, minus 4 times 2 is minus 8 here. So A equal to, so we go back to equation 1 now. So for 1, You know b now. B is equal to 5 minus a, which is 5 minus 2. You have 3. So b equal to 3 now, and c equal to minus 2a. For equation 3 double prime is minus 2 times 2 is minus 4. So c is equal to minus 4, a equal to 2, b equal to 3. So that means that the expression now is equal to a is equal to what now? You check again what you find for value of a. So value of a is equal to 2 in the calculation, right? Value of a is, as we know that a plus b equal to 5, so, and we know a is equal to 2 from a calculation, so b is equal to 5 minus a is 5 minus 2, which is 3. And c equal to minus 2a, so this is minus 2 times 2, you get minus 4. So, therefore, we know that this number a is equal to 2 now, b is equal to 3 now, c equal to 4. Minus 4, sorry. Minus 4. So, in the end, into partial fraction, this is actually 2 over x plus 1 plus 3 over x minus 1 minus 4 over x minus 1 squared, which is equal to 5x squared minus 8x minus 5 over x plus 1 x minus 1 squared.